approximations. Okay, so basically what we have here is you write the equation of a tangent line and you use it. Okay, so you might have a question like, give me a function. Not easy, but not real difficult.
Sine x.
Not easy.
X squared.
Easy.
3x squared.
Easy.
3x squared times 2x to the fourth.
Too easy. It's a power rule problem. Okay, I'll make one up.
Fine. Add
4 over 3. How about we take one off our own? So this is 4 over 3x.
Alright, let's start here. Okay.
Oh, because sine x was in the power.
No, that's a hard problem because it's a, if we calculate the derivative, it's a product rule, not just a power rule. Okay, so you might see, right, the equation of the tangent line at x equals pi over 4. Just because you said it. So we need f at pi over 4, right? As the point, which is pi over 4 cosine pi over 4, okay, which is pi root 2 over 8, right? So far it's a pre-calculus problem. You've just evaluated a function. And this is, all right, so can you write part of your equation already?
Yep, that's y.
Y minus
Y minus pi root 2 over 8.
the y value. That's definitely getting rid of this. Pi root 2 over 8. And the x value is? Okay. That's part right there. How do I calculate? Okay, how much get you? Get so excited. We are missing slope.
Yep.
How do I calculate slope here? Okay, evaluate the derivative. So the derivative is?
Those x plus negative sign.
Yeah, it's a product. So we have a product rule. Derive. Copy plus copy and then derive. Okay. And then evaluate at power 4. That looks fun. Root 2 over 2 plus power 4 times negative root 2 over 2. So, do I need to simplify that anymore? Yeah, it's going to be an calculator problem, so I need to make room for it though. Just write it like it is. Root 2 over 2 minus pi root 2 over 8 times x minus. Okay. So that's something we've done many times. correct? So there's your slope. Bless you, hey, don't hold that in. Blow a gasket. You think I'm kidding? Sneezes come out at over 100 miles an hour.
For real?
Yeah, do you like to hold hurricane force winds inside your body?
Yes.
No, just blow it into your sleeve and wipe it off. You're good to go.
What's the point of wiping it off?
You're going to spread your germs that way. Okay, so that we've done. Here's the extension. Approximate. F at what's power 4 as a decimal?
Not pleasant.
0.2 using the equation of the tangent line.
I found it's actually 0.78.
Oh, this is
The power of 4.
0.78. Okay, let's change this thing. 0.5. We'll be close. All right, so we're going to take some close value and approximate. So we're not going to plug it in the actual function. We're going to plug it into that equation. So that's why we're approximating.
So you're plugging that into X.
Yeah, so this is our x value, right? So y minus pi root 2 over 8 equals ugliness times 0.5 minus pi over 4. So plug it into your linear approximation, your equation of the tangent line. And those are kind of synonyms. And you have one step to be done. You don't have a calculator. How do I isolate y?
You move the 5.
Add this, not it. Give a specific item. I know what we should be doing this. So y equals okay. There you go. No calculator, perfectly acceptable answer.
That was it.
Yeah.
Okay.
So you've got your y value now. It's an approximate, correct? I'll show you graphically what that means after you write it all down. It's embarrassing. I don't care. It's not embarrassing. Natural bodily function. Let's just not start.
According to Mrs. Organizing, she's sarcastic.
All right, so here's what we've done. Here's what we've done graphically. So I don't know what the graph of x cosine x looks like. Actually, it looks like this. Okay. So somewhere at like power 4, we have a point, correct? This is power 4 and pi root 2 over 8. That point. And we have a tangent line. Correct? We've used that tangent line to estimate the value of f at 0.5. Okay, are those lines matching up exactly? The curve and the tangent line are in different spots, right? The tangent line touches once, but it comes off of the curve. There's a distance between the two. Okay, so this is an approximation, not the exact value. Okay, so you just approximated the value of the function. It's a technique they used to use in the old days without calculators because it was pretty darn close. And close enough, because they didn't have rocket science back then. They didn't need to go to 30 decimal places to shoot Saddam Hussein's Scud missiles out of the sky. Okay. They need to build pyramids. That's close enough. So, that's a linear approximation. Okay.
So
All right.
what is that data view exactly? It's just that distance.
What?
So is it, are you estimating the y value? Of the
Yeah. You're not getting the actual, you're getting an estimate based on the equation of 10. You want me to scale it better? Okay, here. Okay, here's a point, right? Okay, this would be the actual location in a different spot, right? An approximation would calculate this point. See how they're different? Close enough in the old days, right?
Why couldn't they just calculate it right there?
Well, they didn't know the value. They didn't even have some, like back in the old days, they didn't have even the cosine, sine, tangent functions. Right, they had to approximate. So. And they've come up with since then better methods, like Euler's method, but this is what we're worried about, so we're going to focus on that. Okay. All right. So here's an AP problem from 2013, I believe. It's number 6. Okay, so consider the differential equation. Okay, we just had one of those on our test, right? And this part, let y equals f of x be the particular solution for the differential that passes through 1, 0. We have to anti-derive this. I'll show you how to do that next semester. Okay, so we're not going to worry about it now, but to get back to the original, you have to anti-derive. Okay. What you're concerned about is write an equation for the line tangent of a graph at 1, 0. Use the tangent line to approximate f at 1.2. Okay. So we already have the derivative, correct?
Yeah.
And we already have the point. So I can already write part of my equation with 1, 0. Right? How do I grab the slope? Evaluate the derivative at 1, 0. So e to the 0, 3, 1 squared minus 6 times 1.
0, 0, 1.
The 0 is 1. 3 minus 6 is, and that goes right there. Sometimes they hand you the equation on a silver platter if you just go get it. Okay, how do I approximate f at 1.2? Approximately. Plug 1.2 in, right? And I don't need to go any further. A little easier than the last one, right? That kind of started you off hard. That's it. You're done. Are you itching to do the arithmetic there?
Yeah.
Yeah, me too. Calm down. It's okay. It's for your response. Just leave it. Okay. I'm not going to give you the satisfaction. Any questions? It's an easy 2 points. Okay, it really is. Okay, here's another one, same question. Same type of question. This is 2014. Okay. Sensing a theme here. This question pops up about every year or two. It's on every year for sure, every other year for sure, at least half the time, sometimes 2 out of 3, 3 out of 4.
Was it on?
Okay, so we will be ready to answer these questions. Alright, so I'm showing it to you. Okay. So same question, same procedure. Okay. We're about out of time already.
Yeah.
Okay, this is a little one.
Grass clipping.
Grass
The
clipping.
grass clip, I told you about the grass clipping problem, right? They're decomposing, woohoo, why do I want to do math about that? Okay, because I told you to. This is a calculator-friendly problem. I will show you how to tackle this with your calculator. But look at D. You're going to do the linear approximation at 30. And then use that at 0.5. So this is the same question. Okay, you need the derivative and a point at 30. You approximate at 0.5. Okay, so it's the same procedure. It's just a word problem. Any questions? Okay. There are. Let's see here. Oh, I didn't put it on here. Fantastic. Some AP free responses that you'll have. I've posted those. I think I already posted everything on Classroom. Okay, so there you go. It's all free responses practice. Okay? Pay attention to the no calculator versus calculator. You are doing yourself a huge disservice if you cheat on that. Okay? This says no calculator. 3, 4, 5, and 6 on the AP exam are no calculator. Do not use one. Okay? Awesome.